So there's this notion of a fitness function, of course, many of them simultaneously in the real world. But the part that this adds to evolution is an incredible speed up, and in fact, I think some minimal intelligence, because when you are dealing with material that can, and in fact, I have a student, Lakshman, who recently we recently published an interesting story on this, where if you are dealing with a material that itself has competency, meaning that it's not just a passive material, exactly what the genome says, that's what it does. It actually, during development, it has the opportunity to fix up some things, and if things aren't quite right, it will make up for some of these defects. Then something very interesting happens. When imagine that you have an individual and it comes up for selection, and it's pretty good. It does a pretty good job. Whatever it's doing, it does a pretty good job. Selection can't tell whether it does a really good job because the genome was amazing, or whether it does a good job because the competency fixed up for some of the things that were wrong in the genome, right? And then this becomes, as soon as that happens, the selection has a really hard time picking the best genomes. What it can do is pick the most competent individuals. So you got this crazy feedback loop, right? Where now more and more of the effort goes into increasing the intelligence of the system, because and the more you do that, the harder it is to see the genome again. Somebody,
it's like many variables optimization functions that you need, to modify each one of the variables, and you don't know which one of them is responsible for the optimization function.
That's exactly right, and you will never know. And Steve Frank gave me a really fun analogy from computer hardware, which is that he says that as RAID arrays became more popular, for hard drives, the quality of the media went down, because you don't need to have such great media once you have a RAID array, and that sort of feeds itself, right? But the trick is it's a one-way ratchet, because once you depend on you can't now remove your RAID array and stick with your disk, because the disks are junk. And so that explains some amazing puzzles in biology, including the planaria, and probably you will want to talk about this, but there are some...
Yes, the two-headed planarian, but before the two-headed planaria, we needed to pay respect to the Picasso frog, okay? So we had the eye on the tail frog, and now we're going to the Picasso frog. And again, this is not CRISPR. This is not that you take the sequence of AGCT and you cut. This is like the face, and I put the face over here. This is something completely different. You take the cells that somehow this is a cell of the mouth, and you put it in a different location.
Yep. There are many ways to I'll talk about how we did it. There are many ways to mess up this process of craniofacial morphogenesis.